Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today, inshallah, we will talk about, um, we will discuss the advanced statistics, partial least squares structural equation modeling, or PLS SAM. So when we do research, there are many kinds of data analysis that we can perform um, on the data. For example, descriptive statistics, um, causal relationship, and causal relationship. There are many types of analysis to test the causal relationships among variables. One of the common methods is multiple regression analysis, and the other one, which is more advanced, is a partial least squares structural equation modeling that we will discuss today. So data analysis using PLS SAM. Why we want to do PLS SAM when we have other kinds of data analysis such as multiple regression analysis? One of the reasons for using PLSM is when the structural model is complex. When we have a complex theoretical framework, then PLSM is appropriate. So the structural model of any research, which is complex, that contains many variables, many constructs. For example, a study that includes many independent variables, and they have missing variable, uh, dependent variable, moderating variables. So this kind of framework is complex, and therefore one of the data analysis that has been used to test this complex relationships among the variables is called PLSM. According to Hare and others, 2011, the selection of PLSM is more appropriate when extending an existing theory. For example, okay, the theory of TPB. There are many research or many studies that have tried to extend the theory of TPB, for example. And so the use of PLSM is appropriate in this case. Another advantage of PLSM is that it can estimate the measurement model and structural model simultaneously. We will discuss what the measurement model is and what the structural model is. What do we mean by measurement model? What do we mean by structural model? Right, can you hear me?
Yes, I'm here.
So data analysis using PLSM involves three stages. The first stage involves data screening process and diagnostic checking or diagnostic test to satisfy multivariate assumptions. So in the first stage, we want to screen data to check for outliers or to check for missing data. Okay, and then we want to test, we want to do the diagnostic checking or diagnostic test to see if the data has any problems or not. And the purpose of the first stage is to test whether the data is suitable. Suitable here means if the data has problems or not. Okay. So if if the data has certain problems, we need to do the what we call remedial measures. We have to do something to make the data suitable. If the data is not suitable and you run the data, then the result or the findings is you cannot make any statistical inference about the findings because the findings is questionable. So the first stage is very important.
Hello?
Uh,
Hello?
Hello, Ahmad, can you hear me or not?
Let one. No, no, I can hear you, sir.
Okay. So the first stage is in the first stage we want to do the screening of the data and we want to check whether the data is suitable, whether the data has problems or not. Problems such as we want to test whether the data is normal or not, whether the data has multicollinearity problems or not.
Hello. Hello. Hello.
Hello, Assalamualaikum.
Walaikum salam wa barakatuh.
Can you hear me now?
Yes, sir. Now it's pretty clear.
Okay,
Alhamdulillah.
I just got this headphone.
Alhamdulillah. Yeah. Good. Alhamdulillah.
Okay, so let's continue the second stage in PLS is performing the assessment of what we call measurement model.
Okay.
Um Today we will just go through the theory, and then in the next lecture we will do the practical.
Okay.
So the second stage we measure, uh, we assess or we calculate the measurement model
Okay.
to identify the underlying structure of the variables involved. So in this stage, we want to see what items what items pass the validity and reliability test. In other words, we want to test. Okay, for example, we have 5 items to test a variable. To we have 5 items in one to measure the variable, right? So among the 5 items, we want to test which items is valid and which item is not valid. So there are so it's very important that only items that pass the test of validity and reliability is used in the next step. So the purpose of the the second test, the second stage is to identify the underlying structure of the variables. So we want to test for each variables which items are valid and reliable and which items are not. Those that are not those items that do not pass the validity and reliability have to be deleted. So after that, in the third stage, we perform the assessment of structural model. This is the final stage where this final stage will tell us the path coefficients, means which coefficients are significant and which coefficient or which variable are significant and which variables are not significant. So that is the final stage. So based on the final stage, um, which is the assessment of the measurement model, we will be able to reveal the findings of the study. So only 3 stages are involved in using the PLS SAM. So the most important is the third stage, the last stage. Um, we call the assessment of the structural model, and the data is run using partial least squares structural equation modeling. Uh, at this stage, it will tell us which variables are significant and which variables are not significant. So the last stage, the measurement model is done using PLS algorithm techniques. So there is a PLS package that we can download from Google. that we will download later, and then we will try to use some of the data uh, to test, to run the data to get the idea of how to use the PLSM. So the measurement model is done using PLS algorithm technique to validate measurement scale of a construct. Variables that pass this analysis test are then used in the structural model analysis to examine the relationship between the endogenous variables and the exogenous variables. So in the final stage, we want to see which, for example, the, which independent variables are significant, which independent variables have no significant relationships with the dependent variables. So let's discuss in more detail each of the stages in PLSM. So in the first stage, we call data screening process and diagnostic test. All data before we go to the second stage and third stage, all data needs to go through data screening process. Okay, so according to Hare, 2006, Hare and others, 2010, before performing the assessment of measurement model, then and the measurement of structural model, the process needs to go through data screening process and diagnostic checking or diagnostic test. What is data screening process? Data screening process involves detecting missing data and outliers. When we collect questionnaires, for example, there are some respondents who do not answer all the questions, who do not tick all the answers. So we call that missing data. Some of the data are not ticked or are not answered. Outliers means there are some respondents who give answers which are outliers, which are totally different from most of the rest. So maybe one or two are outliers. Outliers means the response given are, outlier, strange, and different from others. So the purpose of checking missing data and outliers is to clean the data. So if the data is missing, then we cannot use. And if there's outlier, what do we do? So we need to clean the data before analyzing it using the multivariate analysis. So partially squares structural equation modeling is called multivariate analysis. In order to manage missing data, researchers need to obtain descriptive information to identify the number of questionnaires which contain missing data. So we will check the missing data. We can check using SPSS or using PLS SEM. If the number of questionnaires which contain full information is enough for the purpose of analysis, then the questionnaires that contains the missing data we will not use. We'll throw out the questionnaires that contains missing data. However, if the number of samples is not enough, the remedial measures of data are undertaken. So there are some types of remedy or remedial measures that researchers can take. Okay, and then we need to detect outliers. Okay, we can use the multivariate detection to check multivariate outliers. We use Mahalanobis distances or D-square test. A questionnaire is said to be a multivariate outlier if the value of D-square over degree of freedom is 2.5 in small samples and 3 or 4 in larger samples. So if the value of d square over degree of freedom is 2.5 in small samples or 3 or 4 in larger samples, then the questionnaire has outliers. So according to Hare and others 2010, outliers should be retained unless demonstrable proof indicates that they are truly aberrant and not representative of any observations in the population. So if there are outliers means the response that are different from others. Should we throw it out or should we retain? Should we keep it or should we throw it out? According to Hare, it should be retained unless there is proof that the outliers are not representative of the observations. Because in the population, sometimes there are people who, who are strange, who are outliers, who are not like other people. If they do portray a representative element or segment of the population, they should be retained to ensure generalizability to the entire population. Otherwise, if it is retained, otherwise, if it is deleted, um, it should be deleted if if in the population there is no outliers. So this one for students they need to discuss with their supervisors. Should we delete or should we retain the outliers? Okay, suppose we delete. After deleting outliers, the researcher runs the risk of improving the multivariate analysis but limiting its generalizability. So the choice of whether to retain or to choose or to retain or to delete the outliers depends on the population. If we think that in the population there are outliers, then it should be retained. However, if we think that in the population there is no outlier, there is no strange people, then it should be deleted. So for students, you need to discuss with your supervisors. Okay, after undergoing the data screening process, then the data that we run, okay, the data that we collect, that we input needs to go through diagnostic tests to fulfill multivariate assumptions. There are three tests that is normally performed to test the problems underlying the data. Number one is normality test. Number two, linearity test. Number three, multicollinearity test. So these tests need to be performed before assessment of measurement model in stage 2 and assessment of structural model in stage 3 is performed. Normality test is performed to test whether or not scores for each variable have a normal distribution. The value of skewness and kurtosis are used to guide as a guide to measure normality. So this is the statistics. This is how we calculate the skewness. The statistical value Z for the skewness is calculated as Z skewness equal to skewness divided by square root of 6 over n. Okay, where n is the sample size. And a Z value for kurtosis is calculated as follows. Z kurtosis equals kurtosis over the square root of 24 over n, where n is the sample size. So if either calculated Z, if the calculated Z value exceeds the specified critical value based on the table of skewness and kurtosis, then the distribution is not normal. Data is said to be normal at 99% confidence level if the value of Z skewness and Z kurtosis is less than plus minus 2.58 at 0.01 significance level and plus minus 1.96 at 0.05 significance level. So which critical value you want to choose, it depends. Some people, they want to choose the 0.01 significance level. So they compare the value of Z skewness and Z kurtosis to 2.58. But the researchers can also choose 0.05 significance level. So in this case, the value of Z skewness and kurtosis is compared to plus minus 1.96. For example, if the value of Z skewness and Z kurtosis exceeds 1.96, then the distribution is not normal. So in addition, the researchers can also need also to perform linearity tests to examine whether or not there is a linear relationship between two variables. To test for linearity, the data can be plotted using scatter plot and meshed linear line. And then the last multivariate assumption is that there is no multicollinearity. Multicollinearity exists when there is a high correlation between two independent variables or more. So if two of the independent variables or more have high relationships among them, then the problem of multicollinearity is said to exist. So the high correlation between two or more independent variables will reduce the predictive power of the variables. Hare and others, 2006. How do we test for multicollinearity? A method to test the multicollinearity is by examining tolerance value and variance inflation factor. Based on tolerance value and variance inflation factor, multicollinearity is said to exist if tolerance value is less than the cutoff thresholds, which is 0.10. So if the VIF, for example, is less than 0.10, then multicollinearity is said to exist. Okay, we will do the practical later. All right, that is the first stage. So let me repeat. In the first stage, we test for we do the data screening process, and we test for the existence of problems in data. We want to test whether the data is normal. We want to test whether there is linearity among variables. And we want to test a multicollinearity. That is whether there are strong correlations among two variables or more variables. All right. So in the second stage, after the first stage was done, so after undergoing data screening process and taking remedial measures to overcome the problems of normality, linearity, and multicollinearity, then we can do the assessment of measurement model. The purpose of the second stage, the assessment of measurement model, are to examine basic dimensions of the constructs, number two, to validate the dimensions, and number three, to determine the number of dimensions for each of the constructs. So each of the constructs or variables have dimensions. So in the second stage, we want to examine the basic dimensions. For example, if one variable has, for example, 6 constructs, so maybe there are certain dimensions. So that's what the purpose of the second stage. How many dimensions in the constructs? And then we want to try to validate the dimensions and determine the number of dimensions for each of the constructs. So assessment of measurement model includes composite reliability and average variance extracted AVE to determine reliability and validity respectively. Okay, so the first test is called composite reliability to test the reliability of the items. The purpose of assessing composite reliability is to determine the internal consistency and reliability of a construct or variable. On the other hand, the purpose of assessing average variance extracted AVE is to evaluate the convergent validity. So there are two tests that we want to perform. One is reliability, the second one is validity. So in PLSM, to test for reliability, we use a composite reliability test. Okay. So composite reliability test, the purpose is to examine the internal consistency and reliability of the variable or the construct. And AVE is used to test the validity. We call the convergent validity. So, for example, if your study includes variables such as um, attitude, this is just an example. Suppose your study has attitude, subjective norms, knowledge, self-efficacy, perception towards promotional exposure, and other variables, right? So there are many variables that in this study. So the one of the steps is to test for reliability. So reliability is important to determine consistency and stability of instruments with the concepts which are to be measured. Reliability test is an early indicator to determine the quality of an instrument. Traditionally, Cronbach's alpha procedure is used to determine the reliability of a construct. However, researchers, uh, so some researchers, they use a Cronbach's alpha to test the reliability of a construct. However, uh, the problem with Cronbach's alpha is that Cronbach's alpha assumes that all items are equally reliable. That is, all items have equal outer loadings on the construct. However, this we can use PLSM, which prioritizes the items according to their individual reliability. So nowadays, some researchers no longer use Cronbach's alpha, but they use composite reliability. So the advantage of using composite reliability is that composite reliability takes into consideration the different outer loadings of the items in the construct. What is outer loadings? Outer loadings is the statistical measure given uh, outer loadings is one of the statistical measures to determine the reliability of an item. For example, you have one item, you have one for example, one construct has 8 items, for example. The question is out of 8 items, which one is valid. Which one is reliable, right? Are all 8 items reliable? That's what we want to test. And in order to test that, one of the common measure is called composite reliability, to test the reliability of the item chosen in the construct. So this is the formula of composite reliability. Rho C. Rho C is composite reliability. Rho C equals sigma Li in bracket square over sigma Li square plus sigma VAR EI square. So that is the formula to calculate composite reliability. Li stands for what? Li stands for the standardized outer loading of item I of a construct. EI is the measurement error of item I, and VAREI represents the variance of measurement error, which is defined as 1 minus Li squared. Do you need to calculate all of this manually? The answer is no. Okay, if you use PLSM, um, they will the PLSM will calculate for you using this formula. You don't have to calculate manually. So the composite reliability values range between 0 and 1. The higher the composite reliability, the higher the level of reliability. So we want to have the higher value of composite reliability. The higher the level of reliability, the higher the composite reliability value, the higher the level of reliability. So according to Hare 2014, if composite reliability values of 0.6 to 0.7, then it is acceptable. So all these values will be calculated for you. You don't have to calculate manually. Composite reliability values of less than 0.6 show a lack of internal consistent reliability. So as a researcher, you need to decide if composite reliability is less than 0.6, what do you do? So you want to discuss with your supervisor. Okay, that is composite reliability, to test for reliability of items in the construct. Then let's discuss convergent validity. Convergent validity refers to the extent to which an item correlates positively with alternative items of the same construct. So we want to test whether one item in certain construct has a relationship or correlates with other items in the same construct. The items of a specific construct should converge, which means share a high proportion of variance. To evaluate convergent validity, these researchers can assess the outer loadings of the items together with the AVE, average variance extracted. If auto loadings of items in a specific construct are high, then it means that the items have much in common which is captured by the construct. This situation is called indicator reliability. All auto loadings of all items should be statistically significant and should be at least 0.708 according to Hare and others 2014. If the auto loadings are less than 0.708, then researchers should examine the effects of removing the item on composite reliability. According to Hare and others 2014, they suggested that items having auto loadings between 0.4 and 0.7 should be removed only if the removal of the items leads to increase in composite reliability and AVE. Items having autoloadings of less than 0.4 must be eliminated or deleted from the construct. So researchers can use AVEs to establish convergent validity as suggested by Hare et al. Hare et al. 2014. AVE is defined as the mean value of the squared loadings of the items associated with a specific construct. It measures the sum of the squared loadings divided by the number of items in the construct. AVE is calculated as a mean variance extracted for the items loading on a construct. This is the formula, but you don't have to calculate manually. PLSM will calculate for you. AVE is the sum of Li squared over N, where Li is the standardized factor loading and I is the number of items. And AVE of 0.5 or higher shows adequate convergence. So if the value of AVE is 0.5 or higher, it shows that there is adequate convergence. The minimum acceptable value of AVE is 0.5 because an AVE of 0.5 or higher means that the construct explains more than half of the variance of its items. If AVE is less than 0.5, it means that the average, it means that on average, more errors remain in the items than the variance explained by the construct. Here is the rule to choose whether the constructs are valid or not. The rules for autoloading testing are summarized as follows. If autoloading is less than 0.4, then delete the item. If autoloading is greater than 0.4 but less than 0.7, then analyze the effect of deleting the item on AVE and composite reliability. If deletion increases AVE and composite reliability, then delete the item. However, if item deletion does not increase AVE and composite reliability, then retain the item. All right. If autoloading is greater than 0.7, then retain the item. Based on the those criteria, researchers can decide the dimensions or factors to be included in the study. Okay. In the third stage is assessment of structural model. So this is the last and most important step in PLSM. After confirming that the items in the construct are reliable and valid, then the researchers should perform assessment of structural model. There are 4 steps. The first step is assess the significance and relevance of the structural model relationship. So first we need to run a PLS SAM algorithm in order to obtain the structural model relationship, which indicate hypothesized relationships among constructs in the theoretical framework. So we want to test in our theoretical framework which variables are significant and which variables are not significant. So we test the path, we call the path coefficients. So in the path coefficients, okay, it shows path coefficients which have standardized values between -1 and +1. Estimated path coefficients close to +1 represent strong positive relationships. On the other hand, estimated path coefficients close to -1 represent strong negative relationships. If the estimated coefficients are closer to 0, it shows weaker relationships. If the estimated coefficients are very close to 0, the relationships are not significant. In the step 2, we assess the coefficient of determination R square and adjusted R square. The coefficient of determination R square is the most commonly used measure to evaluate structural model. R square is calculated as the squared correlation between a construct's actual and predicted values. It measures the model's predictive accuracy. The R square value ranges from 0 to 1. The higher the R square, the higher the levels of predictive accuracy. One problem with using R square as the model's predictive accuracy is that any addition of non-significant constructs to a structural model will increase R square. So if researchers add any variable to the construct, it will definitely increase R square. Therefore, using R square as a measure of goodness of model is not a good approach. This is because any addition of any construct, whether significant or not, will always lead to higher R square. Therefore, we need to use adjusted R square to avoid bias towards selecting models with many constructs. This is the formula for adjusted R square. Adjusted R square equals 1 minus R square times n minus 1 over n minus k minus 1, where n here refers to sample size and k is the number of constructs. Therefore, adjusted R square decreases R square by the number of constructs and the sample size, and then penalize addition of non-significant constructs. So if researchers add any non-significant constructs, then the value of adjusted R square will decrease. Okay, and then the assessment of mediating effect. Okay, inshallah we will continue in the next lecture.
Inshallah, sir.
Inshallah, in the next lecture, we will do the practical. I will
Okay.
show you the actual data
Okay.
that I collected, and then how we want to run the data using
Inshallah.
the PLS SAM. So
Inshallah.
there are 3 steps in PLS SAM, and inshallah I will show you how to run and analyze the data using the 3 stages of assessment in the PLS SAM. Okay, I think that's all the class for today.
Inshallah, sir. Thank you so much.
You're welcome. Ahmad, try to be ready, and inshallah next class next week, you can present your chapter 2 and chapter 3.
Yeah, inshallah. I will try my best this week, inshallah.
Okay, inshallah.
Inshallah.
Okay, that's all our class for today.
Okay.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum assalam wa rahmatullahi wa barakatuh.